Okay, so what we looked at before was we looked at factoring any expression using a greatest common factor. So we would find that and work out backwards. Well, today we're going to be looking at specifically quadratics, and we're going to look at how we factor in a different way. Excuse me. Okay, remember back to when we looked at examples for how to multiply binomials. We took a function that was already in intercept form, and then we used distributing to put it into standard form. Now, if you remember, we looked at, let me get my pen ready here, just a second. Okay. We looked at how we're going to take this x right here and multiply it by the entire binomial. And then we're going to take this positive 2 and again multiply it by the entire binomial. Normally we skip this step when we're writing it out, but I wanted to show this to you for a very important reason. After we do that, we have two middle terms. Both of them are x terms. They're like terms, and when we combine them down, that's how we get our middle term here. Now this is in standard form, which remember is y equals ax squared plus bx plus c. A, b, and c. In this case, a would be 3, b would be 5, c would be negative 2. Okay. Well, remember when we did the GCF, we said we were undistributing. Well, that's what we're going to be doing exactly the same here, except remember we distributed twice. So that makes it a little bit trickier. When we're just looking at any general expression, we'll look at, functions with a y equals in a minute. But just as a regular expression, the easiest way I think to set this up is by using these, what I call a diamond problem. I know it looks like an X. It's a long story, but I call it a diamond. So you can call it whatever you want. The way we're going to set up this diamond is by using the A, B, and C values from standard form. Now here we have A and C. What we're going to do is multiply those together to get A and C on the top. A times C, whatever that number is, we'll put it on the top. Then we take the B value and we put that in the bottom of the diamond. Now the way that you solve a diamond problem like this is we're trying to figure out two numbers, one on either side, and what we want to be true about those numbers is that if I multiply the two of them together, I get whatever number is on the top. And if I add the two of them together, I get the number on the bottom. So you have to really think about your factors of the different numbers. And so this is the first step to being able to factor these. This is probably the most important step out of the whole thing. So let's look at how we can apply that diamond. So here's an example. 4x squared plus 12x equals negative 7. Let's go ahead and figure out how we would complete a diamond for this particular expression. First, we're going to set it up with our x. The number that goes on the top comes from multiplying A times C. 4 times negative 7 is negative 28. So that's the number I'm going to put on top. And then my B goes on the bottom. It would just be 12. What we're trying to decide here now is what two things might multiply to make negative 28 and add together to make positive 12. Some of you may know this already. You may have already figured out what two numbers it's going to be. But if you're unsure and if you ever can't think of it, don't leave it blank because you won't be able to do the rest of the problem without this. What I do is I start with listing out my factors. 1 times 28 is 28. 2 times 14 is 28. 3 doesn't go into 28. 4 times 7 is 28. And that's it. There's nothing else that are going to be factors. Some things that you notice here is since I need to multiply to get a negative 28, that means one of my numbers has to be a negative and one of them has to be a positive. And so I can see by knowing that 2 and 14 is going to work. I need my answer to be a positive 12. So that means that I'm going to have positive 14 and negative 2. Just to review why this diamond works, if I do negative 2 and positive 14 and multiply them together, I get negative 28. But if I add the two of them together, I get positive 12. And so that's how it is that we figure out what two numbers have to go there. And a lot of people get frustrated trying to figure these out. There is no real easy way to do it. Okay, you're gonna have to just kind of play around with numbers, guess and check. Start with the top and start thinking about what multiplies together to that top number. Once you figure out things that multiply, then you want to test with adding or subtracting if you're going to have negatives to figure out what the bottom number is going to be. Okay, don't give up on these diamonds. Sometimes, like I said, you just need to list out the factors. That's going to be the easiest way to help you out if you get stuck there. Okay, so what do we do once we have figured that out? We're going to do what's called factoring by grouping. Okay, we've already done the diamond for this one. But one thing that I want to point out is anytime we're trying to factor, we always want to check for a GCF. Because if there is one, we're going to need to pull it out before we do the rest of the problem. So if I look at this, 4x squared, 12x, and negative 7, there is no greatest common factor there other than 1. And if it's positive 1, it's really irrelevant. So we don't need to worry about a GCF here. Now, we already did our diamond. We said negative 28, positive 12, and we figured out that it was 14 and negative 2. Just to point out, it does not matter which one goes on which side. I could have put negative 2 and positive 14. There's no reason why one is better than the other. But here's what this diamond just figured out for us. And I want you to think back to the first example that we did about how to distribute 2 times. What these two numbers from our diamond give us is they tell us what 2 terms we combined to get 12x. So since we're working backwards, we're going to split that apart. So I want to split this apart to now say 4x squared plus 14x minus 2x minus 7. So just again to point out, this 14 is why I got a 14x, and this negative 2 is why I got a negative 2x. Remember, if we were working the other direction, we'd then combine those to get 12x, but we're trying to undo all of that distributing that we've done. Okay. The next step now, and this is why this is called grouping, you should always have 4 terms at this point. You're going to chop it in half right after the end of the second term. Remember that negative belongs to the 2, so don't include that when you chop it off. And what we're going to do now is we're going to look for a GCF twice. We need a GCF in this first part, and we need a GCF in the second part. So if I look at 4x squared plus 14x, I can take out a 2x. When I do that, 2x times 2x gives me 4x squared, and 2x times 7 gives me 14x. Now I'm going to look at the second part, negative 2x minus 7. Remember, if your leading term, in this case negative 2x, if it's negative, your GCF has to be negative. And in this case, the only thing I can take out is a minus 1. When I do that, though, all my signs change, and I get 2x plus 7. Now, what you should see at this point, and it should be this way every single time, is you see that we have this common factor. All right? So what we need to do now is we know that this common factor was what we had multiplied by twice, and these 2 pieces were the 2 things that I multiplied it by. And so here I have my 2 factors. This would be your answer. We've taken that expression from standard form to factored form. 2x minus 1 times 2x plus 7. Okay, let's look back really quickly at the first example that we did. Let's go backwards here. Hold on. Remember from this first example when we were multiplying, factoring is going backwards. So if we look at this instead from the bottom up, this is where we started. I could do the diamond problem on this. I would get 3 times negative 2, I would put negative 6 on the top. B goes on the bottom, that would be 5. And the 2 answers that I would get here is that negative 1 times positive 6 multiplies to negative 6, adds to positive 5. Well, look at what we got here. Here's my -1. Here's my +6. That's exactly what that diamond figures out. And then after we chop it in half and take our GCFs, we end up with this common factor here. And remember, that was what we distributed with twice. That's how we know to put the x and the +2 back together to give you this original factor. So that's how we can undistribute something where we had to do a double distribution, aka FOIL. Okay? Let's look at another example. That would be my dog growling. Just ignore him. Okay, here is another example. To set up our diamond, hold on. Let's go to, okay, this is a good example because this one has a greatest common factor. And so that's, remember, that should be your first step no matter what you do. Any kind of problem, you need to be checking for a greatest common factor. So if we look at this, the GCF is 3. So that means I'm going to factor out a 3. That gives me x squared minus 3x minus 10. From here, okay, from this point on, until we get to our final answer, we're going to ignore the GCF. We're only going to work on factoring what is inside those parentheses there. So to do that, we will set up our diamond problem. Now, A is 1, C is -10. So when I multiply those, I get -10. And B is -3. Make sure you pay attention to the signs. If you get the signs wrong, the whole thing's going to be wrong. So we have to think of things that multiply to 10. 1 times 10, not going to give me 3. 2 times 5, well, if I make one of those negative, I can get 3. Since I need a -3, that means the bigger number has to be negative. 2 plus -5 gives me -3. Okay? Now we're going to go to do the grouping. The only thing that we change is that middle term, the x. The x squared stays the same. The -10 stays the same. We're just taking that -3x and basically undoing that combining like term step. So I have plus 2x because that was a +2 minus 5x because that was a -5. And now we chop it up. The GCF of the first half, we can take out an x. That leaves me with x times x plus 2. The GCF of the second half is a -5, which gives me x plus 2. Do we have a common term here? Do they match? The answer is yes, because we have x plus 2 and x plus 2. So as long as we have that, now we pull apart the x minus 5. That was the two parts that I distributed. And then the x plus 2 was the common factor that I distributed too. But we cannot forget this guy that we started with up here because he's still part of the problem. So finally, we just bring down the GCF. So this is the factored form, and it's factored completely because we also took out the greatest common factor of 3x squared minus 9x minus 30. Okay? I'm going to stop there. If you're feeling comfortable with this, go ahead and move on and look at the problems. If you need to look at some extra examples, there's an extra video with more examples that you can look at. So hopefully that is helpful to you. Okay? I will see you guys later.